Hello friends, myself already Mahajan presenting my video on numerical differentiation. What is by numerical differentiation? It is the technique of finding the value of the derivative of a function at some point x when that function is expressed in terms of tabulated values. Means it is not directly given as a function like sin x, cos x or e raised to x. It is expressed in terms of tabulated values. Then that process is called as numerical differentiation. If the value of x is equispaced, then we apply Newton's forward interpolation formula. If the value of x is at the top of the table, then we use Newton's forward interpolation formula to find out that derivative of function fx. Therefore, using that Newton's forward interpolation formula, we have y is equal to y0 plus p into delta y0 plus p into p minus 1 by 2 factorial into del square y0. Next, plus p minus 1, p minus 2 divided by 3 factorial del cube y0 and so on. This is the Newton's forward interpolation formula. We call this as equation 1. Then the value of p is x minus x0 by h. It is x minus x0 by h, where h is the distance between two successive values of x. Then what we do, we differentiate it with respect to p. Differentiating 1 with respect to p. Therefore, we get dy by dp as differentiation of this y0 with respect to p. It is a constant with respect to p, therefore its derivative is 0. Differentiation of this second term with respect to p is delta y0. This one is p square minus p. Its differentiation is 2p minus 1 divided by 2 factorial into del square y0. Next one, if we perform the product of this, it is p minus 1 into p minus 2. It becomes p cube minus 3p square plus 2p, and therefore differentiating it with respect to p, we get that as 3p square minus 6p and plus 2 divided by 3 factorial into del cube y0 and so on. Therefore, we have first, second and third term after differentiating it with respect to p, and so on. We can have some more terms. Then rewriting it, differentiating that p with respect to x, we get dp by dx as it is 1 by h, constant term outside, and derivative of x with respect to x is 1, and therefore we get the value of dp by dx as 1 by h. And therefore rewriting this dy by dp as dy by dx is equal to dy by dp into dp by dx. We get it is equals to, if we put the value of dp by dx, the value of dp by dx is here 1 by h, and then into dy by dp, the value of dy by dp is delta y0 plus 2p minus 2 divided by 2 factorial into del square y0. Next one is three p square minus 6p plus 2 divided by 3 factorial del cube y0 If you try to find out the next one more term, we get that term as rewriting this dy by dp as dy by dx is equal to dy by dp into dp by dx. Dp get cancelled, we get original dy by dx, and therefore it is equals to the value of dp by dx is 1 by h, and value of dy by dp from equation from the previous step, it is delta y0 2p minus 1 by 2 factor into del square y0 plus 3p square minus 6p plus 2 divided by 3 factorial into del cube y0. We can extend, we can write next term as, but for that we have to take the next term in the Newton's forward interpolation formula. It is p minus 1, p minus 2, p minus 3 divided by 4 factorial into del raised to 4 y0. And by differentiating that term, we get 4p cube minus 18p square plus 22p minus 6 divided by 4 factorial into del raised to 4 y0. Therefore, whenever we require to find the first order derivative for that given table using Newton's forward interpolation formula, we are supposed to apply this formula. Okay. Then we try to see another case when that x is equal to x0. When x is equal to x0, that value of p becomes 0. Therefore, that is the subcase for it. When x is equal to x0, if we put x is equal to x0 here, it is x0 minus x0 means it becomes 0. We get the value of p as 0. And if p becomes 0, that dy by dx means first order derivative at x is equal to x0 becomes, here it is 1 by h delta y0. P becomes 0, therefore it is minus 2 by 2 factorial, it is minus, small correction here in this result, I have written 2p minus 2, instead of that the term is 2p minus 1 divided by 2 factorial, therefore make this small correction. Then substituting p is equals to 0, this becomes 0, 1 by 2 del square y0. Next 0, 0, 2 by 6. 2 by 6 means it is 1 by 3 del cube y0. Next one 0, 0, 0, 6 by 24. 6 by 24, it becomes 1 by 4 minus del raised to 4 y0 and so on. Therefore, this is the sub result or another result to find out first order derivative at the point x is equal to x0. Means what? When that point is itself from the given table, and if it is at the top of the table, we use this result, and if it is in between that two values, then we use this result. Therefore, equation number 3. Therefore, remember these two results. The first one is this one, equation 2, to find out first order derivative, and second result again first order derivative at some x is equal to x0, then it is 1 by h del y0 minus half del square y0 plus 1 by 3 del cube y0 minus 1 by 4 del raised to 4 y0, and so on. Next step is again differentiating this equation 2 with respect to p. We get d2y by dx square is equal to 1 by h into that 1 by h, it becomes 1 by h square, and then differentiating each and every term with respect to p. Its derivative 0, its derivative is 2 divided by 2 factorial, we get del square y0. Its differentiation is 6p minus 6 divided by 3 factorial into del cube y0. Next, it is 12p square minus 36p plus 22, 12p square minus 36p plus 22 divided by 4 factorial into del raised to 4 y0, and so on. Therefore, this is the formula to find out the second order derivative. Then we try to see the subcase for this. At x is equal to x0, once again we get the value of p at 0, and if we put that value of p at 0, we get one more result, that is d2y by dx square at x is equal to x0 is 1 by h square, del square y0 remains as it is, p0, therefore 6 by 6 we get cancelled, we get minus del cube y0, then 0 0, 22 by 24, 22 by 24 we get 11 by 12, 11 by 12 del raised to 4 y0, and if you try to find the next term, we get terms alternately positive negative minus we keep this up to this only, therefore so on. We call this equation number 5. Therefore, this, remember these two results, equation 4 and equation 5, to find out second order derivative when that point lies in the top of the table, obtained by Newton's forward interpolation formula. Therefore, in this part I have discussed 4 different results to find out first order as well as second order derivative. I will discuss one simple example based on these formulas. Let us try to solve the problem. Find dy by dx as well as d2y by dx square at x is equal to 1 for the given data. That table is, the values of x are 0, 1, 2, 3, 4, 5. Distance between the 2 points is 1, equidistance, equispace. Means we can apply Newton's formula or Newton's interpolation formula. Y is equal to 4, 8, 15, 7, 6, 2. And then what is required? We require to find dy by dx and d2y by dx square at x is equal to 1. Therefore, x is equal to 1 is the given point itself, and which lies at the top of the table, means we have to apply Newton's forward interpolation formula to find out that derivative at point x is equal to 1. And therefore, for that, first of all, we have to prepare that table. Therefore, preparing that table, we get preparing forward difference table. Given data, values of x and y are x0, 1, 2, 3, 4, 5, and the corresponding values of y are 4, 8, 15, 7, 6, and 2. Then first difference, del y, 8 minus 4 we get 4, 15 minus 8 we get 7, 7 minus 15 we get minus 8, 6 minus 7 we get minus 1, and 2 minus 6 we get minus 4. Second difference, del square y. It is the differences of this difference. 7 minus 4 we get 3. Minus 8 minus 7 we get minus 15. Minus 1 plus 8, it becomes 7. Minus 4 plus 1 we get minus 3. Therefore 3 minus 15, 7 and minus 3. These are the values. Then third order difference is the differences of this difference. Therefore minus 15 minus 3 we get minus 18. 7 plus 15 we get 22. Then minus 3 minus 7 we get minus 10. We write the values in between that two values while writing that forward difference table. Then the last one, del raised to 4y, 22 minus minus plus 18. 22 plus 18 we get 40. Then minus 10 minus 22 we get minus 32. And the last fifth difference is the differences of this. Minus 32 minus 40 we get minus 72. Therefore this is the forward difference. Then the value at which we require to find the derivative is 1, second value. The corresponding second value is 8. Therefore we underline that two values. And then we consider the second values from this table. Therefore we underline this 7, minus 15, 22 and minus 32. These are the values of del y0, del square y0, del cube y0 and del raised to 4y0. Here P is x minus x0 by h. We consider this one as x, therefore 1 minus 1 we get the value of p as 0. That is the subcase. And when p is 0, we have the formula by Newton's forward interpolation formula. We get differentiation of that y with respect to x. We get dy by dx at x is equal to some x0 is 1 by h delta y0 minus 1 by 2 del square y0. Terms alternately positive negative. Already I have discussed this in the first part. Plus 1 by 3 del cube y0. Then minus 1 by 4 del raised to 4 y0 and so on. This is the formula we have to apply. And then substituting the values, corresponding values. Here the value of h is difference between these two is 1, therefore 1 by 1. Delta y0, the value of delta y0 is 7 minus 1 by 2. Del square y0, the value of del square y0 is minus 15. Then 1 by 3. Del cube, the value of del cube is 22. Minus 1 by 4. Del raised to 4. The value of del raised to 4 is minus 32. And then simplifying it, it is 7 minus minus plus 15 by 2. Then 22 by 3. Then plus 32 by 4. We can simplify it further. This one is 7. 32 by 4. 8 plus 8. Then 15 by 2 plus and plus 22 by 3. And finding the simplified value by calculator, we get it is 7 plus 8. 7 plus 8 plus 15 by 2 and plus 22 by 3. 22 by 3, we get that value as 179 divided by 6. 179 divided by 6. 179 divided by 6. And if we find out it in fractional form, it is 179 divided by 6. We get that value as 29.83. 29.83. Therefore, dy by dx at x is equal to dy by dx at x is equal to 1. By Newton's forward interpolation formula, we get that value as 29.83. This is called as a numerical differentiation. Value of derivative obtained with the help of the given tabulated values. Therefore, this is the first result, dy by dx at x is equal to 1. Then we try to find out the second value, d2y by dx square at x is equal to 1. d2y by dx square at x is equal to h0 is given by 1 by h square, del square y0 minus del cube y0, terms alternately positive negative, plus 11 by 12 del raised to 4 y0 and so on. Then we have to substitute the corresponding values from the table. Here h is 1, therefore 1 by 1 square, 1 by 1. Del square y0, the value of del square y0 is minus 15, minus del cube y0, the value of del cube y0 is 22, plus 11 by 12, del raised to 4 y0, the value of del raised to 4 y0 is minus 32. And then simplifying it, this one is minus 15, minus 22, minus 11 by 6. If we divide by 2, we get 16. Dividing by 2, we get 12 by 2, 6. And if we divide by 2 here, it is 32 by 2, 16. With minus sign, it is the addition of all this term. Therefore, it is 15 plus 22 plus 11 by 6 into 16 199 by 3 199 by 3, and if you find in decimal point, it is 199 divided by 3 as 66.33. with minus sign, 66.33. Therefore, this is the value of d2y by dx square at x is equal to 1. That value is minus 66.33 as the required answer. Therefore, with the help of this example, I have explained how we can find the first order as well as second order derivative when that point is at the top of the table and as the point itself from that table. It is not in between the two values. Therefore, this is the technique. In my next video, I will discuss how we can obtain the first order as well as second order derivatives when that point lies in the bottom of the table. In the bottom of the table means we have to apply Newton's backward interpolation formula to derive that formulas. That I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel to get a notification. For that, you have to press the bell icon to receive the notification of all my new videos. Thank you very much.